Actually, before I get started talking to some of that stuff, just kind of following along with a bit of the economic analysis we were doing a few minutes ago. I don't know how many of you guys know about this site called the Privacy Rights Clearinghouse. They track data breaches. They started in January of 2005. And I gave a talk one time where I just sort of like expounded on this for a while. And at the end of their list, it'll tell you the number of total records breached, right? And it's an ongoing list. So it's up to something like 400 million now. A guy named Larry Ponemon, runs Ponemon Institute, did a report where he studied how much does it cost to recover from an attack. And he said that the average cost, based on his research with organizations, was $202 per record to recover from an attack. So when I see stuff like that, I like to do math. So the slide is a bit old. It's over 400 million breached records now. But if you just take it at the time I built the slide, multiply it together, I mean, so a year ago, from 2005, $51 billion has been lost from attacks, and it makes me ask questions like that. And so then I start thinking, gee, what could we have done? Well, we could have bought 393 million barrels of oil, could have sent 2 million people to the University of Washington last year. Here's one that kind of hits home for some people, saved the lives of 82,000 people. I like this one especially. If we just built secure systems and we didn't get hacked, then we could feed 4.5 million or 5.4 million families every year. Anyway, I just thought I'd kind of show that. I thought it was interesting since we were talking a little bit about some of the economics of attacks. Who am I? I'm from Amazon Web Services. I have kind of the enviable or maybe unenviable position of becoming the guy who goes and talks publicly about AWS security. So some people think that's really cool. Some of my colleagues think that's really cool. Our PR department is completely scared to death of everything that comes out of my mouth. But we are looking at ways we can be more transparent, because we absolutely realize that the only way we're going to continue to win business is by addressing the elephant in the room, which is how do you protect data on an infrastructure that you don't own? So I'm going to go through pretty quickly here, because I actually did think of a few questions that I want to ruminate on with you guys together near the end of the talk. Because I've got some ideas about some things I want to do next, and I'd like to help you guys, or I'd like you guys to help me prioritize that. And if you have any questions or comments as I'm kind of going through some of the material, that's okay. Just please let me know. So am I not filling the room enough? All right. So, are you recording it? Oh, okay. All right. Turn it on. Okay, so now this is posterity, so I really have to be careful what I'm saying. One of the things that Hoff talked about in the beginning was resiliency and redundancy being kind of important. And so, yeah, we do view that as a critical element of being secure. And to help you build applications that can be resilient, we've got data centers and facilities in 4 areas of the world for compute and storage, and 16 areas of the world for content distribution. I think probably what gets a little bit more interesting is what happens in some of those facilities. So we break down a geographic region into language we use. We call this an availability zone. Now, it isn't exactly the same as a single building, but that's sort of how I've depicted it on the picture here. Most regions have 2 availability zones. On U.S. East, on the East Coast in Virginia, we've got 4 availability zones. What do you get with an availability zone? Well, as much as we can, we try to keep them separated geographically. You don't want to flood bringing down all 4 of your data centers, so we separate them when we can. Or earthquake. A little difficult in Singapore, for example, because it's one tiny little island. It is one single floodplain. It is one geographically area. But we do what we can, right? Now, I'm going to get into this a little bit later. Depending on the particular way you're storing data, we're going to make multiple copies of that for you. So again, this is this idea of sort of built-in resiliency. And that might be moved between availability zones within a region. The important thing to understand is that we will never move data automatically from one geographic region to another. Because we understand that in many instances, you might be bound by regulatory requirements that say data that goes in Europe has to stay in Europe. So if you put it in the data center in Ireland, you can be confident that it's going to stay in Ireland. It will not, on its own, move to Northern California. Now, you're free to move it if you want to. You can. We're not going to stop you from doing that, but we don't do any region moving automatically. Yeah?
Is that defined by data site or by political zone? Or is it the data site, this data site in Ireland or Ireland?
So, yeah, you say this is Republican data and this is Democratic data. Is that what you mean? No, it's... no, yeah, you say what we do is give you the region. So EU West is the region, right? Or US West or US East or APAC. Now, if you want to start an instance, not only do you pick the region, but you also pick the availability zone. You want that instance to go in as well. Good. There. All right. We don't actually draw attention to them. You know, there's one instance where security by obscurity actually makes sense, and we think that's in where the facilities are. And so, you know, when we construct something like this, we actually don't put an Amazon sign on it. There's pretty high degree of physical security that's required to get into the buildings. You get, you know, I'm not allowed, even though, I mean, my job is to communicate about AWS security to people, because I don't have a role that requires getting physical access to the facilities. I actually can't get in there. I don't have any permissions to do that. Only our operators can. Everything is logged, probably on that ancient dot matrix printer right there, too, I think. Now, let's talk a little bit about what happens with the services and the data movement. So with S3, which is, just think of it as like, you know, persistent disk in the cloud, simple DB, which is a simple flat file database, and multi-AZ RDS. So RDS is a relational database service that we released several months ago. Instead of starting an instance and then installing MySQL on it, RDS is a pre-configured MySQL for you. You can get that now in multi-AZs. When you store an object, so let's say it's a Windows machine and you X-copy something onto, you know, like a D drive that's a, well, no, say you put it in S3. D drive would be EBS, sorry. So you put it in S3. We will make multiple copies of that, and we will put that in multiple availability zones automatically. That's just part of the feature. We make a distinction between service level agreement and durability. So the service level agreement for S3 is 99.999%. The durability is 11 nines. We have recently announced something called the reduced redundancy storage for Amazon S3. So instead of 11 nines, I think it's, is it 9 nines for reduced redundancy? Yep, okay. Too many numbers. I mean, I used to work for Microsoft, right? Going from a company that releases a new product every 7 years to a new company that releases a new product every 7 days is a mental challenge to memorize all this stuff. But the idea is, even with the reduced redundancy, you still get those multiple copies. It just isn't as many copies as you get. EBS, I need to define probably what EBS is first. So when you start an instance, you get some disk that goes with the instance. That disk is for the operating system. That disk is not durable. Right? So there's this whole notion of servers are disposable horsepower. They come and go. Don't worry about debugging things. Just terminate and restart. What matters a lot more now is the data and what you do to protect that data. So if you're going to build a database server, you want to go grab some disk somewhere. That's what Elastic Block Store is all about. And then you attach that to your instance. In that case, because that is disk that's attached to a virtual machine, and virtual machines live in only one availability zone, an EBS volume lives in only one availability zone, but we still will make multiple copies of that information for you. And you know, you write something, and a half an hour later, you want to read the thing you wrote back, and if your read request happens to land on a drive that died at that very moment, we will detect that that drive failure happened, and we'll just send you off to another one of those copies and give you that back. We don't even give you an error message. But our operators will know that, you know, drive 7 in frame 5 in building 4 died, and so they'll go in and replace that drive. So what does that mean when that drive dies? I'll get to that in a minute. So on EC2, the compute cloud, the disk that's there, we call that ephemeral storage. And we don't want you to rely on that for anything. I'll tell you a quick story. One of the things that helped me learn a little bit about some of these details on how some of this disk stuff works, we had a customer who had a SQL server that was, the database was on the instance store. It wasn't on an EBS volume. And read our recommendation and said, you know, that's really not the way to do that because it's not durable. He said, yeah, okay, I better replicate that stuff off. So he fired up a replication job, which is going to take a little bit of while, or a little bit of time. So he went home that evening. His boss logs into the management console from home, sees this another instance running that's replicating data, and says, I don't know what that is, and hits the terminate button on both of them. Now, then they call us, and they want us to restore his data. Well, we can't really do that for you. Let me tell you why. When you allocate an EBS volume, we go, logically it looks like a volume to you, right? But really what we do is we go find unused disk space, assemble that together into a volume upon which you can put a file system. But before it shows up as available in the console for you, we are zeroing out those blocks. So there's a little bit of delay there, right? So you get nice, fresh, clean physical blocks as well, and then you put your file system on top of it. But for all of the rest of the services, what we do is rely on the virtualization layer where we create a logical to physical block mapping, right? So that whenever you get disk, if there's data that's already on the disk, you can't read it because we mark that data as being owned by somebody else. So since it's not your data, even though there might be something on the, the physical magnetic surface there, the logical mapping table prevents you from reading that. And so here's an interesting thing that I learned in this experience with this guy with the SQL server. If you were to get into one of our data centers, physically get into the data center and actually yank a disk out of the thing, you're not going to be able to make any sense out of the data that's on there. It's a collection of bits from a variety of customers. There's no context that makes sense to you as an analyst of the data that's there. So it's just essentially a bunch of scrambled bits at the physical layer. It only makes sense at the customer layer, at the layer that you can see. So that's how disk is handled. Now, what do we do with CPU? Yep.
Is it just more of a property of how you strike, or is that a security property?
Yeah, that's kind of an interesting question.
In the broad sense.
It's more of it's a mechanism that we keep in place to make sure that the hardware is as maximally utilized as possible, right? So just by making sure that we keep that hardware in use and that it doesn't sit there idle. But it also allows us to spread the data out across multiple pieces of hardware. So if you've got a 300 meg file, it's actually quicker to read that thing back because it might be coming from 18 physical drives all at once, right? Even though it looks like a single volume to you. It's just part of the architecture. And then you get a security benefit out of that, right? Because only we know what's happening at the physical layer, and that's not exposed at the logical layer. And even at the physical layer, our operators can't make sense out of that data because it's lacking the context.
So would it be fair to say, using something like a Linux file system as a comparison,
Yeah.
all the metadata that you would normally see in IO tables is stored somewhere else. You're just allocating big blocks.
Right. Yeah. I mean, at our level, at the physical level, we can't even make a distinction between a GIF image and the inodes that would go with that, right? We don't see that. Is there another question? Yeah.
Just extending on that, so this could be done randomly just to optimize for space and reuse it, or optimize for probability of exploitation. Is there an optimization of one of the?
Not really. No. It's Yep. Yeah, and it's even more than obscurity. It's the fact that at a certain level the information is not even there, right? Yeah.
And it's also the probability of a single disk failure.
Yeah. That's I wonder what the number is. You maybe just think about something. I wonder how many drives we lose a day. I don't know. Probably a lot, given the number of, like for example, I think there's over 130 billion objects in Amazon S3 right now. So you got to think about the number of drives it takes to store all that.
Do you prefer the question as we go, or should we say
I'm totally okay like this, guys. I'm just the one on the stage with the PowerPoint, right? I like this kind of format. Yeah. Okay, I'm going to talk about encryption a little bit, right? So let's just kind of hang off on that for a bit. Now, at the instance level, we use Zen. That is our hypervisor. And there's just a couple interesting things about our implementation of Zen that I think you might find kind of interesting. Our administrators, of course, can manage the physical machines. All of that is done remotely, and that's done via SSH, so that we've got some degree of protection. We know who that person is. We know where they're coming from. You, as the customer, have complete control of the VM. So when you start a VM, you choose what operating system you want to run, and then from there, we don't have access to that stuff anymore. We don't look into what's happening in the memory. We don't know what operating system you're running. We don't know whether you are or are not violating the license of the application that you install. We hope that you're not violating the license of that. But we're very, very clear about data belonging to you and your VMs belonging to you, and that we have a high degree of procedural as well as technical isolation between our operators and what you're doing. Yep. 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 Okay, so I want to talk about that a little bit, right? So this is the question that people always seem to really like to ask, right? What are you doing to isolate one virtual machine from another? So we've got this concept called security groups, which is one way, this is one of many elements that we use to isolate VMs. Now, I said that we use Zen, and we add some customizations to Zen. This is the most important customization that we add. When you start a virtual machine, you must associate that machine with a construct that we call a security group. Now, I'm going to explore them in a little bit more. I'm going to give you how you would link some of these together. Security group. A security group is a definition, think of it as a semi-stateful firewall. It's a list of the traffic that's allowed into the box. So you give the rule, and you can have multiple rules in a group. You give the rule a name. You indicate the destination protocol and port number, and the source IP address or origin. Now just park the word origin in your brain for a minute, because I'm going to define that momentarily. All right? And the default group is default deny, right? You actually have to open up the security group, and then you associate that to an instance. Now, the code for the security groups that's part of our secret sauce, and that lives in the hypervisor, right? So this is one of the things that helps to isolate VMs from each other. Now, like all responsible software companies, we do have a pretty stringent security development lifecycle. We do regular penetration testing for the code that we do, and we also rely on outside third parties as well to take a look at this. I feel really confident in this code. I don't know of any occasions of where there has actually been cross-VM communications, because all of the datagrams that travel between VMs are actually associated with a particular customer ID as well. Right? And that is going to become important when I talk to you about how you can build virtual network tiers in an infrastructure where there are no separate virtual networks. So it is a pretty flat network that we have. But people are typically used to thinking in tiers, right? So how do you replicate what you're accustomed to doing in something that physically looks very, very different? So I wrote about this on the AWS blog several weeks ago, and the blog post was basically kind of what I'm going to tell you now. I use this diagram to show what a typical 3-tier requirement might look like. So the web tier, you allow traffic in from the internet. You also might allow management traffic from your CorpNet, right? You might want to RDP into the box. If it's a Windows box, you're probably going to have to do that if you want to log in and manage the thing. At the application tier, you're going to allow traffic to come in from the web tier. And at the database tier, you're going to allow traffic to come in from the application tier. Now, there's a number of ways that you could actually go about creating this. And one of them is you could use the AWS console. So we have a GUI console that exposes most of the functionality of AWS. And in this instance here, I've created the Web Application Security Group. And you can see that it allows inbound traffic from the internet, which is defined as 0000/0, to destination ports 80 and 443 TCP. I'm also allowing inbound traffic to destination 3389 from my CorpNet, and I invented that IP address range, okay? Now, of course, somebody could try to spoof that IP address range. That's why you're going to rely on something like SSH or the RDP security features, so you actually have to log into a user account on the machine to manage it.
I think I heard you say that the customer ID is...
I'll get to that, okay? Yeah. I tend to sort of bounce around because I like to put things in your brain and then come back to them. It's a bad habit, I know, but it's the way we do things. So here's the application security tier. All right, now take a look at that. You can see I've still got a line there that allows RDP traffic from the CorpNet, but note that the source is not a set of IP addresses, 0000, but is the named security group, right? So the only machines that can talk to the application tier are machines that live in the security group labeled WebSG. Now, what if somebody else has a security group also named WebSG? This is where your customer ID comes into play, right? Only your app SG, as defined by your customer ID, allows only your security groups to talk, right? So somebody else's WebSG won't come through this rule. Only your WebSG will come through this rule.
So, by way of comparison, would it be fair to say that your customer ID as a tag and your rule name is really just functioning as a super rule?
Yeah, and it's part of what happens. In a minute, I'm going to actually show you the API calls. And I've left out an element in the API call because I just didn't have room to put on the PowerPoint. But when you are using things at the API, you actually have to sign every request so that we know that it's yours, right? It'll become a little bit clearer in a minute. I sort of like to do the graphical version first because I then need to tell you why you don't want to do it this way. Actually, I think I can probably tell you that right now. Yeah, take a look at the defined port range for the WebSG. Basically, at the GUI, when you use a security group as the origin, it opens it up for all ports on TCP, all ports on UDP, and all types for ICMP. Currently, right now today, the security group functionality in the console reflects the capabilities of an older version of the API. Now, this is for backward compatibility, okay? In a minute, I'm going to show you the better way to do this. But I just, in the spirit of transparency, I need to let you know how things happen right now. Here's the last one, the database group. And notice that, I'm opening it to two things, my CorpNet plus my database vendor. And then, like before, I'm allowing only the app security group to talk. Yes, sir?
Looks like with the list that doesn't even allow traffic to in a group, for the more machine side talking about machine side group.
Well, so if two machines are in the same security group, these rules still apply.
So there would be
No. The better way to do this is with the APIs. So we have a set of command line utilities that you could use. I'm a UI guy. I grew up in the Microsoft world. I love to point and click. But when it comes to defining security groups, I'm going to use the APIs because the APIs actually expose the current degree, I'll get to just a second, the current degree of functionality. And if you'll note there that using the APIs, when I'm defining the rules for the app security group, I can actually indicate the particular ports and protocols that we should listen on. So I can get a little bit more fine-grained. The plan is to bring the console up to parity with the current API. I don't know what the timeline is on that, but I just want to make sure that you understand that for this particular thing, please install the command line tools and use the APIs to configure your security groups. Yes? No. An instance cannot be attached to more than one security group at a time. And that is another thing, too. Once you start an instance and indicate what security group it belongs in, you can't change that. right? If you need to change the secured group that an instance is in, you actually have to terminate the instance and restart it and move it over.
Is there an implicit denial?
Yeah, yes, yes, yes. Now, I want to introduce something to you. So in a couple of the talks before I came up here, people were talking about the notion of web application firewalls or doing some kind of inspection. Take a look. What's open to the internet right now? The web server, right? What if we add another tier? And for sake of better language and color, I use dark purple and black, and I call it the inspection tier. And I've named it the inspection security group. I think this is kind of an interesting concept. Instead of exposing the web servers directly to the internet, why don't you instead put them inside a security group that only allows inbound connections from an instance in which you've installed a web application firewall, or an IDS, or an IPS, or whatever you want, right? You've got complete freedom in how you structure these rules to interact with each other and build whatever level of tiers, whatever degree of traffic path that you want to do. And one of the things that's sort of on my list of things to do is actually sort of document how you can do this. There's a feature called Virtual Private Cloud that instead of creating instances that have internet access, they live behind an IPsec tunnel mode security association between a gateway on our side and a gateway on your side. And you have to define routing in your infrastructure that allows traffic on your CorpNet to talk to these instances. They don't have any internet access currently. Probably the most confusing thing to do is to remember to, in your network, write the return routes. I used to build VPNs for a living. I always left out the return routes. Could never figure out why my pings went but never came back. Just something to know. Here's where what you can do with VPC right now. It's still in beta. So things in VPC are only in one availability zone in either Virginia or Ireland. We don't have that everywhere yet, but it's planned. We are also looking at multiple AZs and multiple routers. I love this idea of multiple routers into a single VPC. Imagine someday when there's no central IT anymore. I know that all makes you get really frightened right when you hear about that. But think about a bunch of regional offices all with routers connecting to a single VPC, and everything's in a VPC, including your domain controllers. S3, our storage system, the most important thing I want to highlight your attention to is that when you put an ACL on a bucket, which is like a folder, the ACLs on those objects do not inherit. You actually have to define them on the objects themselves. It's not like normal operating systems are. So I said I wanted to talk about encryption for a minute. I'm going to do that right now. There is no encryption by default in AWS, right? Yes?
Before we go
Yep.
into encryption, I noticed you put IPsec.
Yeah.
A very complex protocol. Are you agnostic to use OpenVPN just as equally?
Oh, okay, so this requires that you have to define an IPsec tunnel mode security association, AES 128, SHA-1, perfect forward secrecy, and BGP. Yeah, that's how that works. Now, if you wanted to build your own VPN environment with public EC2, absolutely, surely you could use OpenVPN, and we've got a lot of customers who are doing that, right? But those machines might also have internet access. This is sort of a way of saying, that's my machine. I left out kind of an interesting attribute. These machines, they don't get any IP addresses. You define the IP address. So it literally is a box on your network. It just happens to be physically located in ours. All right, so encryption, just briefly. You don't get any encryption by default with AWS, but you are absolutely free to use whatever encryption that you want. Our IT department is in the process of working through their policies and procedures for moving Exchange, SharePoint, and Office Communication Server onto Amazon VPC. I'm intimately involved in this project. And one of the things that they're looking at doing is using IPsec for machine-to-machine communication, primarily because that way we can authenticate both ends of the connection. And then they're going to use BitLocker to encrypt the data volumes. So that will work. Running BitLocker on a data volume that is an EBS volume absolutely will work. If you've got Linux volumes, you can use whatever is appropriate for you. We don't place any limits on what kind of encryption technology you might want to use. Yeah. Okay, so yeah, right now there's no TPM virtualization. So no, the Windows 2008 instances, even though you can use BitLocker, it will not use TPM. So you're going to have to either store those keys in the registry or do something else with them. And we're actually working with Microsoft on what a best practice would be in that case, especially because BitLocker data volumes are not automatically unlocked when their server boots, right? So this is sort of like kind of my home, the AWS Security Center, aws.amazon.com/security. And it already looks a little bit different than that now because we've put some new information up there. We have now published a procedure for how to report vulnerabilities. We are encouraging that if researchers or customers find a vulnerability in the system, that they report that to us. We have a dedicated email address for that, aws-security@amazon.com. There is an SLA associated with that. We will be assigning CVSS scoring to do security bulletins, and we do request responsible disclosure for that. We also have published a penetration testing policy. If you want to do penetration testing of your applications, that is entirely allowed. All we ask is that you ask permission first. We're going to send you a form. You have to fill out the form. The form does limit the kinds of tools you can use. Our legal department asked at the very beginning that we limit those tools. We're working with trying to allow you to use a broader set of tools for that. Really, the only thing we ask that you don't do is please do not do denial of service tests, because that causes our security guys to spin up in unnecessary cycles. We will not allow you to do denial of service tests, but you're free to do penetration testing at the application level. And we also have a PGP key out now if you need to send this to us and you want to protect it that way. So we'd love to talk about compliance. Just a couple updates on compliance. Turns out that the HITECH Act is going to have some changes in the HIPAA, so I'm working on rewriting that. We've gone through the second SAS 70 Type 2 round, and we've made it much easier for you to see that now. ISO 27001 and FISMA are in progress. Here are some things I'm working on. I know I'm running out of time. I'm just going to run through this really, really quickly, and then I'll be here all day so we can talk about this one-on-one a little bit later. What does it mean to be compliant when you don't own the infrastructure? I think there's some interesting guidance that I could put together, but I'd love some feedback on what you would like that to look like. And also, one thing that's on my mind is how to make it very clear and understandable where our security ends and where your security begins. That's probably my highest priority thing of some research and some reporting that I want to do. So, I want to thank the CSA very much for giving me the opportunity. We are not members of the CSA yet. We're trying as hard as I can to convince the organization that it's good for us, good for you. But I'm here for you. That's, I was sent here to talk, but I want to listen as much as I can get a hold of me. Thanks a lot. Appreciate the time.